Okay, class, so we're going to take a look at the second derivative test, and this will be the last section that we'll be doing for the semester. So if you can, please turn to page 6 in your blue packet. This should be titled Chapter 3.4, Second Derivative Test. So what we're going to do is we can actually use a shortcut to find maximum and minimums, and that's using the second derivative to do this. So we are going to kind of create a mix of the first derivative test and the second derivative test to find out whether or not we have a local max or min. So, well, we're skipping this page, but we are going to start on a page that looks like this. So if you take a look at the notation here, this says if f prime of c is equal to 0 and f double prime of c is greater than 0, which means it's positive, then f of x has a local minimum at x equals c. And the second one says if f prime of c equals 0 and f double prime of c is less than 0, then f of x has a local maximum at x equals c. So let's kind of put this into our terms that we use in class. What is it called when I take a derivative and set it equal to 0? Alright, so this right here is the same as a critical number. Well, actually, it is a critical number. Anytime I take my derivative, set it equal to 0, and I have an answer, that c is our critical number, right? So if you take a look, this is the same exact thing. I took a derivative, made it equal to 0, find out what that number was, and that c is our critical number. So what this is telling you to do is, well, once you find your critical number, you are going to plug it in to f double prime, or the second derivative. And here's where you start the interpretation. If it is greater than 0, which also means your answer, so f double prime of c, is positive, right? Greater than 0 is positive. Then you're actually going to have a minimum. So think of it as opposites, okay? And then if I plug it in and I get a number that is less than this, so let's use green, less than 0, which means my sign is negative, that tells me that f double prime of c, when it is a negative number, actually has a maximum. So if I were to write these down in steps, I would say step 1 is to find your critical numbers, right? Step 2 is plug your critical numbers into f double prime of x. And then step 3 is to interpret this. So that's what we're going to do on the next problem. Now, the one thing that may occur is the case where f double prime of c is equal to 0. Anytime this occurs, then you are not allowed to use the second derivative test. Okay, so that means the only way to find the answer here is using the first derivative test from before. So let's do one of these problems, and then I'll have you guys do one on your own. So it says, find the x-coordinate of any local extrema using the second derivative test where applicable. So that's the key word, where applicable. Doesn't mean it always works. It means sometimes you may not be able to use the second derivative test. Then it says, justify your answer using the second derivative test. So we know anytime we say the word justify, I am required, yes, you are required to write a sentence stating how you know this is true. And finally, the answers, I just need x coordinates. So first thing we do is I notice I have a function. And let's do this. Let me scoot this up so I have the right power. Okay, so if I take a look at this function, number 1 is to find the critical numbers. So in order to do that, I need f prime of x. And if I do this, I get 12x squared minus 10x plus 2. I'm going to factor this. So I pull out a 2 and I get 6x squared minus 5x plus 1. And if I factor this again, I get 2x minus 1 and 3x minus 1. And if you check your work, it's true. Okay. So I have this derivative that's factored. Next step is to set everything equal to 0. 2 equal to 0, 2x minus 1 is equal to 0, 3x minus 1 is equal to 0. We know this is never true. If I solve this, I move that 1 over and I divide by 2. And if I solve this, I move that 1 over and I divide by 3. So how many critical numbers do I have? Sorry. Okay, good. So I have 3 of these. Now, the next step says you need to plug in your critical numbers into the second derivative. So what I need to do now is find the second derivative by taking this derivative. So I'm going to use this one up here because it's the easiest derivative to take. So I have f double prime of x is equal to 24x minus 10. Right? So power rule, constant coefficient rule, and sorry, this is constant multiple rule, and this one is just 0. So now what I'm going to do is I'm going to take our two critical numbers, 1/2 and 1/3, plug them in here to see what our sign is. So f double prime of 1/2 is the same as 24 times 1/2 minus 10. These cancel and I get 12 minus 10, which is equal to 2. Is 2 positive or negative? Good, it's positive. So anytime this is positive, that's going to tell me that this 1/2 right here is a minimum. Right? Now I need to plug in this 1/3, so I do f double prime of 1 over 3. That gives me 24, 24 times 1 over 3 minus 10. These cancel and I get an 8. 8 minus 10 is equal to negative 2. Since this one has a negative answer, that means this has to be a maximum. So I've answered everything except for the justification. So all you need to say is, and let me write this down. I'll try to write neatly. According to the second derivative test, x equals 1/2 is a minimum. Oh, I'm sorry. Oh, yes, it is a minimum. Since f double prime of 1/2 is greater than 0, and x equals 1/3 is a, sorry, I'm going to scroll down here, is a maximum since f double prime of 1/3 is less than 0, and period. And that's it. So this, for some people, is a lot faster than doing the first derivative test. Usually for multiple choice questions, I would prefer to do this method as opposed to the chart, but sometimes you're required to do the chart for first response. So what I'd like you to do is, if you could please solve this equation for me. I would like you to please find the x-coordinates of the extrema here and tell me if it's a maximum or minimum, and then justify your answer. So good luck, and I will see you later. Take care.